To find the volume of solid formed when the region R bounded by the curves y equal to square root x and the line y equal to 0, line x equal to 4 is revolved about the x-axis. So here we have the region R in the xy plane, and it is going to be revolved about the x-axis. So it's going to come over front and then make one whole revolution. We will watch a demo for this. So here I have the this is the region R in the xy plane, and then we're going to make one revolution here. The solid of revolution formed, it's going to be like this. So we want to visualize a solid there under that surface, blue surface. So we have this solid and we want to find the volume of the solid, and so we're going to use the disk method, where this volume, the solid is sliced into thin disks, and then we're going to use the slice and sum strategy. So where we keep on slicing into extremely thin disks, and as the number of disks becomes larger and larger, so here we can see the actual volume with the approximation. The approximation is the sum of the volume of the disk. Note that each disk is going to be a cylinder, and then we have the cylinder formula, and then we apply the cylinder formula to all of these disks and add it up to get an approximate volume. But as the number of disks becomes larger and larger, the approximation gets better, and then it becomes the actual volume when the number of disks go to infinity. So the strategy is going to be, we're going to draw one disk in this diagram. We're going to draw one disk and then get an expression for the volume of that one disk. Again, the disk being a cylinder, we have the volume formula, and then we're going to continuously add. Continuous addition becomes integration. We're going to take one disk expression and then continuously add from the starting point to the ending point, noting the movement of the direction in which the disks are being added. In this case, we are going to add the disks in the x direction, because we have the smallest disk in the left corner and the largest disk in the right corner. So we're going to go back to the problem. So this is the region R, and we're going to start by taking in disk first by drawing that volume of revolution. So we're going to draw a mirror image here of the region R, and then so this is a point, and this corner point will kind of make a circle. So we're going to kind of finish off that circle, just to visualize that 3D object. And in that, we're going to take at one point x comma y, right? So this point on the curve x comma y satisfies this equation y equal to square root x. And now this slice, this is a super thin slice which rotates to form a disk. So we're kind of going to draw a disk. We want to visualize a disk which is a very, very thin cylinder, and we're going to use that volume formula. So volume will become continuously add. We're going to continuously add all the disks starting from this corner to this corner. So starting from x equal to 0 to x equal to 4, and we're going to add the volume of the disk. So volume of the disk, which is a cylinder formula, is pi r squared times w, where the w is the width of the disk. So I'm going to rewrite this for this problem. So we're going to have x equal to 0 to 4 pi r squared, the dx. So the dx is that very super thin width of that disk. So that is the ds, the thickness of the cylinder. So, and then we're going to replace r by what is the radius of this disk. It is the y value. This vertical value is the y value. So I'm going to put y squared dx, but we're going to integrate with respect to x, so the y should not be there. We're going to replace that y with an expression in x. So we're going to use this y equal to square root x for that. Y squared will become x dx. x equal to 0 to 4. And then now this is ready for integration. Y equal to 0 to 4 x dx, which is pi x squared over 2, 0 to 4 pi 16 over 2, which is 8 pi.